Now you know how loops work. Now we can use them for drawing. In the following, we will use a for loop to repeat the creation of a line. Therefore, let's go to Rhino Grasshopper and move to example number 3, underlining lines. Right-click on the component and enable it, so it becomes light green. And double-click on it to open the code. Here, if we press the Run button, we see the outcome, what we plan to do. So we want to draw a set of lines inside our for loop. And before we've used the for loop only for printing text, now we use the for loop for drawing lines. Let's look into our code. In the beginning, we have the number, a variable, integer variable, iterations, which tells us how many lines we will draw. This is used as the iterator and counting variable for our for loop. So here you see the for loop, which is repeated as long as I is smaller than the number of iterations. Here you see the familiar incrementer I++ means I is increased by 1 in every loop. What we have mentioned already, but now we want to look into it again, is a list. We want to store our lines inside a list in order to send them to the output. And the output is our object A, and to this output we want to send a list of lines. Therefore we need to instantiate the class list of the type line. So to tell our list which data type we want to store in it, that's written in this parentheses, in these brackets. The name of our list is collect lines, and we instantiate it with the keyword new and create a new list. So remember, our list is called collect lines. We will use it after we created a line to store our lines. But now let's look into the creation of the line itself. To create a line, we need a start and an end point. You can also remember how it's been done in Grasshopper. If you create a line parametrically, usually you have a component or two components for the start and end point, and you connect these points to your component that draws a line. Now we want to do the same thing in code. The starting point we call from pt, it's from point from which we start to draw our line. This is a data type point3D, that's from the geometry namespace, which you already know how to look into it, how to access it. To create an instance of the class point3D, we use again the new keyword, and we send 3 parameters to this point3D to create it. These are the x, y, and z coordinates. And once again, as we've looked into it, if you open the parentheses, should not happen. If you open the parentheses, in this version it doesn't work, but usually you see here you see the context menu. So double x, double y, double z. These are my 3 coordinates to create a point. As you see, for the x coordinate, I use the I variable, my counting variable. This means the x coordinate is increased by 1 in each iteration, each step. This is why we draw them beside each other. And for the point to which I want to draw the line, we do the same, point 3D, and we create it In this case, we use a more complicated, or it's not complicated, but we use I more often. Once again, I is the same for the x coordinate, that's why the lines are vertical. For the y coordinate, we use once again a combination of I multiplied by I divided by 10, and z is again 0 because we only draw in 2D. Since I is increasing, we create this kind of exponential growing curve as the endpoint of our lines. This is done by this I multiplied by I, and the divider takes care about the intensity or how fast this exponential curve is growing. So if we set it to 2, you can see the difference, and then it's growing much faster. So I use 10, or we can also look at 20, we can put 20, that's smaller. So 10 creates, because of the lines, that fits very well to my drawing window, therefore it's 10. And be careful or be aware that you have to use your floating point number, because if you use an integer value that we've used here, so 1, 2, 3, 4, 5, and so on, and divide it by an integer value only, then the result will be a rounded integer value. Only if you use a floating point number, the result will be a floating point number as well. This is sometimes the cause of some difficult to find problems. So if I set it to 10, then we see as long as it's rounded to a value below 1, it's 0, no line is drawn at all, and only if it's rounded to numbers bigger than 1, then we see the line. So we need a floating point number. Okay. But so far we have not created the line in our code. To create a line, I again use the keyword line, or create an instance of the class line. This is once again in the geometry namespace, so we could write in before the namespace of our Rhino geometry. Where is it? Let's see it here. Here, Rhino.geometry, we could write the same thing like this. Here, if you make a dot, to remind you, you see all the objects that are in the namespace geometry, and one of them is our line object. And if you run it, nothing changes. This is just to remind you from where this line comes from. It's from our library Rhino.geometry. Okay, and then we use the new keyword to create a new instance of a line, and we draw the line from our point to our point. So these are the two instances from here, the two objects we use as input parameters to create a line. And then in the last step, now remember again, we've created our list of lines where we collect the lines. So in each iteration we add the line that we've created to our list. And we do this as many iterations we've defined, in this case 12. If we change it to 15, we do it a few times more often, so here you see more lines in our report. And after the for loop ends, we continue with the code to a equals to collect line. This means I send my list of lines to my output parameter, which is in my component this one. And as soon as it is outputted here, it's drawn if it's a Rhino geometry object, or an object that Rhino can draw it, and it draws it automatically. Okay, so that's the very basic thing to draw lines. We can now look into the input variables again. So here you see I've connected already two parameters to x and y, which I use in the following example. We can also control the number of lines that we draw, for example, by creating a new input variable, which you do, as you see here, there are the small icons to add a new variable or to remove one with the minus. Now we add one, call it number, press enter, and take care that you close the old code or script window, because otherwise it's not updated. But now if you open it again, you see my run script parameters, they have changed. So here I added a new variable. In this case it's an object, but I don't want an object, I want an integer value. So right click on this variable and go to type, hint, and we want to have an integer. If you double click again on the component, here you see the input variable has changed to an integer. So that's how to change the input. And now I want to create a slider with the number 12, for example, and connect it to my number variable to control it with a slider. And the only thing I have to do in my code is to tell that the number of iterations is not equal, it's not 15, it's an R, so the number that I define by my slider. If you run it and change the number of lines, you can control parametrically how many lines you want to draw. So that's now parametric control of your code. Okay, but let's remove it to a smaller number. Come on. Good. Now we want to continue with playing around with our code. As you can see, I prepared already a few things. We want to now change the way how we draw the lines inside of our for loop. This is to give you an impression on how powerful for loops are, what you can do with them. In this case, I changed the x and y, respectively only the y coordinate, based on a calculation that I do with our I iterating variable. So zoom in here. Here I activate these two lines of code, and I deactivated my old lines, which create the from point and to point again. But what I changed, added, is I used the math class, and in the math class, that's a very important class because it collects a lot of mathematical functions. Here you may be familiar with it from your school time. That's the cosinus function, and I use the I iterator again, divided by 2 and multiplied by a frequency variable. This is what I've declared at the top. Usually variables, it's a good style to structure your code that you declare the variables at the top of your void or the method, the function. And here I create a double variable which equals to x. X comes from my input. You could also set it to a floating point number, but in this case I use the input that comes from my sliders. And I use the intensity variable, which is used in the second line in the definition of the 2 point. Here you see my sinus curve includes the frequency, so divides it by the frequency, multiplies it with the intensity parameter. To understand what happens, press the play button. Now you see, increase it. I control the lines how they are drawn with the sinus and cosinus function. And if you remember, these are these wave forms that they create. And with the functions here, I create for the from point, so these are the points that are here more or less on the horizontal axis, with the frequency parameter from where they start, and the y, so where it ends, it's controlled by the frequency again, and the intensity. So this means I can play around also with these buttons and change how this combination of sinus and cosinus curves look like if I play around with these. Here now you see I changed the intensity, so the length of the lines, and the frequency means how fast it goes up and down, and I can control here my lines and the global form that's created by a set of lines. Okay, this example, I think that's very important to understand how you can use mathematical functions like these basic cosinus and sinus functions inside a for loop to manipulate variables like the from and to points in a way that you create something, some designed curves for some form, for some shape or whatsoever, that is, or that the form, the global form, is created by the repetition of drawing a line element. Good. The last part of this session is that I want to show you how you can manipulate the lines that you've drawn. Therefore, we switch back to the simpler form of our line to understand it easily. So now I draw it with the old form. So here my lines are drawn only 15 again. Here. And now I want to take the lines from my collect lines list and change a parameter from the stored lines. What we use is a for loop, and we loop through all the collect lines, all the collected lines that are in our list. And to know how many elements I have in my list, I use the count method of my list. So this returns me the number 15, because I have 15 elements in my list. And I repeat it as long as it's smaller than 15, because remember we start from the index 0, and we go until 14. So these are in total 15 elements. Here, from the well-known form, increasing the iterator I by 1. What you see is you can use the same variable name I as we've used it here, because this is only valid from here to the end of our loop, our for loop, from here to there. From here on, our compiler doesn't know what I means, so you can use it here again. Well, what we do now is we want to take out a line from our collection of lines. This is done by creating a variable line, so an empty container where we can now take a line from our list of lines and put it into this empty container. To call a specific element in a list, we use this parenthesis and the number, so that's the address of the element in our list, starting with the address 0, that's the first element, we take out the first element. This is this small line, store it here. And now we ask for the 2 point of this line, which is a point 3D, which we read from our line. This is a temporary point, a temp PT. And we ask for the from point from which our line is drawn. What we do is we change, in this case we could deactivate this because we only change this parameter. And what we do is we say the x coordinate from the 2 point, so these are the points at the top of our lines. This point shall be changed concerning the x coordinate, and we want to add the value 9 to it. Remember, plus equals means temp.x, so the x coordinate of our point, plus 9. And then, after we change the point, we need to store it again to our line property. So the property of a line has properties, and the two important ones for us is the property to and from, which we used here. To reads the point to which the line is drawn, and we can also set the point to which the line is drawn with assigning the temp point to it. If you want to see how many or what kind of properties and methods your line has, you can write a dot, and then you see it has a lot of methods. Methods are kind of abilities that the objects can perform, or what you can do with the object. And properties are simple values or data types, structures that are stored in it. So here you see from means you can read the from point. And we've taken the to, it's the point to which the line is drawn. Okay. And after we changed our line, we set it back to our list with the specific address to override the old line which is stored there, or to ensure that it's overwritten. Usually in object-oriented programming you don't need to do this, but in Grasshopper scripting it's necessary that you override this. Or we can test what happens if we don't do this. Because usually it's only referenced, so the objects from a list, if you take them out from your list and change it, the elements in the list know that this element has changed. But in Rhino, respectively Grasshopper, this doesn't work. So we need to override the line in our list, which is not a problem. We can do this with this line of code. And so we need to deactivate the output at the top, and now we want to return the collect lines list with the changed lines. What happens if we run the script? So you see I changed the coordinates of the 2 point a little bit by the value 9, so all the lines are drawn to a point plus 9 in the x direction. We can now check what happens if I don't override this property. You see it doesn't work because the lines in my list, they remain the same as I have added them. I just take out the lines or the points from a line and override the properties, but the list is not updated, so I need to do this. We can also change other elements from our line, for example the from point, which we take out here, and then we change the y coordinate from which the point is drawn. So this these coordinates, we change the y coordinate. We can also change the x a little bit, and then we need to override the from point again with the new point or the temporary point that we manipulated, and since it's the current or the current line, again, this is overwritten here with both change properties. What happens? So we extend the line and change the property from the point here, as we have seen it. Okay, so now you know how to use a for loop for drawing geometries, in our case lines. You know how to include mathematical functions in a for loop, and you have seen how we can take out elements from a collection, from a list of lines, and manipulate these objects and override the elements in the list and return the manipulated objects. That's a very good basis for looking into our next example, which will be about a more complex usage of loops, where we include loops inside of loops. But this will be part of the next session. Please use the code that I provide you and experiment with it, change it, play around with it, change the name of the variables, play around with the numbers, connect new sliders, put them in to control the x and y coordinates of your point. Please work with this code. This is the only way to learn how it works, to become familiar with the logic of your code. So enjoy experimenting and playing around with this code.